All right, hi you guys. Today we are starting day one, block one notes. So we're going to be looking at systems a little bit, and this should be a review hopefully for you. We'll use systems throughout our geometry section here, so we want to review them first. To get us started though, let's take a look at a couple linear equations and just start by graphing them, see what we remember about graphing. So number one here, we're going to graph this equation, y equals 2x minus 4. Now this format hopefully looks familiar to you. You might know it as y equals mx plus b. This is our slope-intercept form. And that helps us graph an equation really easily because we can quickly identify the slope and the y-intercept. So the slope is the m, the y-intercept is in the b spot. So for this equation, the slope, which we use m to represent, is 2, just the coefficient, just the number in front. The y-intercept is negative 4. I'm going to graph this line by graphing the y-intercept first. So I'm going to go down to negative 4. Now I'll use my slope to get another point. Remember, slope is rise over run. I can think of the whole number 2, like 2 divided by 1 or 2 over 1. So I'll go up 2 over 1. Up 2 over 1. Since they're both positive, we're going up and to the right. Now to connect these, if you're using Cami to take your notes, if you're on the drawing tool and then you click down Shift on your keyboard, so hold down Shift, you'll be able to draw a nice straight line because it can be kind of hard to draw lines on here. And then let go of Shift when you're done. Add arrows because it does go on forever. Now we're done. Number 2 doesn't quite look the same. So if I want to graph this guy, one of the easier ways to do it is to convert it to our slope-intercept form. So I'm going to rewrite my equation. X minus 2y equals negative 2. I want to solve this equation for y, meaning I want to get y all by itself. So I'll subtract x first. Negative 2y equals negative x minus 2. Divide by negative 2. So when I divide by negative 2, all of the negatives on the right side will cancel each other out. So now I have y equals, right, because these are gone. Negative over negative becomes just x over 2. Negative 2 divided by negative 2 becomes plus 2 over 2. Right, I can split up that fraction. I can simplify this a little bit further. When there's just a variable with nothing in front, we can write a hidden 1, right? Just like a coefficient of 1 in front of the x. So I'm going to write it as 1 over 2 and then the x next to it, plus 2 over 2. We know that equals the whole number 1. So here's my equation. Graphing this guy, my slope, I can easily see it's 1/2. My y-intercept is positive 1. So I graph the y-intercept first. This time I'm going up 1 over 2. Up 1 over 2. And again, hold the Shift key on your keyboard to draw a nice straight line. Add arrows, and we're done. So let's start looking at systems here. The first problem we'll do with systems is just checking whether a certain point is a solution. So we have a point, x, y. A system is when we have two equations and two variables. So we have a y and an x, and we're trying to figure out the value of both variables. So to check if this point is a solution, I'm just going to plug it into each equation. So I'm going to start with the first one. So instead of a y, I'm going to replace it with negative 7 equals 2 times x, so times negative 4 plus 1. Now I'll simplify. Negative 7 equals negative 8 plus 1. Negative 7 equals negative 7. What I'm looking for is whether this final statement here is true. Does negative 7 equal negative 7? Yes, so that's good. Now I have to check the other one. I'm not looking for these values to be the same. I'm not trying to get -7 again. I just want it to be another true statement. So I'll plug in the values. So 2 times y, 2 times -7 equals 3 times x, 3 times -4 minus 2. -14 equals -12 minus 2. -14 equals -14. So it doesn't matter that I didn't get -7 again. It's that I got another true statement. So that's good. So because both of them were true when I plugged in the point, I say yes, it is a solution. Next, we're going to show 3 ways to solve a system, find the solution. We'll start by graphing. So when I'm graphing, I want to get both equations into slope-intercept form. So I'll start with the first one. 3x minus 2y equals -7. Solve this equation for y. Minus 2y equals -3x minus 7. Divide by -2. Y equals, these negatives again cancel out, so 3 over 2x. Negatives cancel out, plus 7 over 2. Okay. Our second equation, oops, 2x plus y equals 7. Subtract 2x. Y equals -2x plus 7. I like to try to write it in that y equals mx plus b order. So we'll graph both of these. Let's go back to the first one. My slope is 3 over 2. My y-intercept is 7 over 2. If you don't know, this is about 1.5. Not about. This is equal to 1.5. Sorry. And this is equal to 3.5. Oops. So I can graph. I'll plot my y-intercept first. 3.5 right about here. I can use my fraction. It's a little bit easier to use the fraction. So I'm going to go up 3 over 2. So 1, 2, 3 over 2 puts me about here. Hold down the shift key and connect those lines. And then I'm going to plot my other line. So again, my slope, -2. I'm going to write it as a fraction, -2 over 1. My y-intercept, 7. So I'll start by plotting 7. And then because it's a -2, I'm going to go down 2, +1, so still to the right. So down 2 to the right 1, and 2 like that. Hold the shift key, connect the dots. Okay, so I have my 2 lines graphed. I can see where they intersect. That's what I'm looking for. The intersection point is the solution. So that point, 1, 5, is the solution to my system. Okay, but if I don't want to graph, I can solve the exact same system 2 other ways. So we'll go through both of those here. The first way is substitution. This one often is a little bit trickier, not usually people's favorite, but we'll still go through it. So if I'm using substitution, I need to solve one of these equations for a variable, meaning I need to get a variable by itself. So I'm going to take that second equation because it's a little easier. 2x plus y equals 7. I'm going to solve it for y. So minus 2x, we already did this above. Okay, so now I have y all by itself. What I can do is take that first equation, 3x minus 2, but instead of y, I'm going to just write this entire equation. I'm literally plugging it in, substituting it in for y because it equals y. Negative 2x plus 7. And then don't forget to finish equals -7. Okay, so I substituted it in for the variable that it equals. Now I have to solve this. So I'll distribute first, following order of operations. 3x minus, so negative 2 times negative 2 becomes positive 4x minus 14 equals negative 7. Combine like terms, 7x minus 14 equals negative 7. And then just solve for x. 7x equals 7 because I added 14. And x equals 1 after you divide. Not done yet though. I still have to plug in my x value back into one of the equations to solve for y. So I'm going to plug it back into the second equation. It doesn't really matter. So 2 times 1 plus y equals 7. 2 plus y equals 7. Therefore, y equals 5. And this is good because I got the exact same answer that we did when we graphed 1, 5. That's what we should expect because it's the same system. Let's look at the second method. So that was substitution. Method number 2, elimination. This is the method I think most people prefer, and you'll probably use this one the most throughout this geometry unit. So what I'm going to do, let me rewrite the two equations. So I want to eliminate or get rid of an entire variable. Now I can do that by adding the equations together, but they have to have, one of the variables has to have the same coefficient, but opposite signs. So I can see that happening with the y variable already, right? This is a negative 2y and a positive y, but the coefficients don't match. So to fix that, I'm going to multiply the second equation by positive 2. Sometimes you have to multiply by a negative to get those opposite signs, but this one already is worked out. So I'm going to rewrite that top equation. And now after I multiply by positive 2, I multiply everything by 2. This becomes 4x plus 2y equals 14. Now I can add these equations together. So 3x plus 4x becomes 7x. Negative 2y plus 2y, those cancel out. Negative 7 plus 14 is 7. Therefore, x equals 1. So this is already a lot easier than the last method. I still have to plug this back in. Doesn't matter which equation, so I'll plug it in the first one this time. 3 times 1 minus 2y equals negative 7. All right, I'm plugging in for x so that I can solve for y. 3 minus 2y equals negative 7. Solving for y. Negative 2y equals negative 10. Y equals 5. So again, I got the same exact answer, which is good because it's the same system. So you have two problems to work through on the bottom here. You can do any method you want. If you use elimination, you might need to multiply by a negative value to get those opposite signs. And you'll do a little bit of work with fractions over here. But you'll be able to check your answers, and I'll go through how I solve them after you guys give them a try. All right, here are my final answers for those two problems. You can definitely pause the video to look a little bit closer at things. But basically I did elimination for both of them. You don't have to, you could have used substitution if you prefer. For part A, it's pretty easy. I multiplied the top equation by negative 2. So the x variable canceled out. Y equals 2, plug it back in, x equals 1. Second one's a little trickier only because we have fractions. You could have substituted here because we have y equals for both. So they would have basically just been setting the equations equal to each other. But I decided to use elimination. So I multiplied the second equation by negative 1 to get rid of the y variable. And then I had to add fractions, so I did that over here, 2 plus 1/3. Be careful when you're eliminating. If you do that here, y minus y should be 0. It's not just blank. Multiplied by 3 to get rid of the fraction 7/3. At x equals 3, plug it back in, and y equals 2.